one of the things that we can do with these, guys, come on, this will be a lot faster. Come on. One of the things that you can do with these is that so one of the things that we can do is that when you're starting to think about equations and stuff, in order to solve equations, you're using what are called inverse operations, right? If you had to solve, let me move this for a second. If we had 3x equals 9, what do you do to solve for x?
Divide by 3.
Now, you know that you have to divide by 3 because it's the inverse of 3, correct?
Sure.
Now, do you guys ever use an inverse before?
What?
An inverse. Think about this. What is 2 squared? 4. What's 2 cubed?
9.
What's 2 to the first power?
2.
What's 2 to the 0 power?
1.
What's 2 to the negative 1 then?
2.
Oh, is that what
It's 2.
1/2. That, one of the properties you guys work with over time is that we'll start to work with properties of exponents. Exponents, as they go negative, they turn into an inverse property. You put it like x to the negative n is 1 over x. Things like that. I know it's something they touch on very, very briefly in an algebra class, but you see a lot more of it in algebra 2. That symbol just means it's an inverse. You're using an inverse operation because 3 to the negative 1, you're multiplying it by both sides. Because 3 to the negative 1 is 1/3. 1/3 times 3 is an inverse. Their inverses one another becomes 1. So what we can do here is that we can actually take these nasty looking problems and create what's called a matrix. So if I take the last example you guys were all complaining about, I'm going to create what's called a coefficient matrix. A matrix is basically a system of a way of gathering information. Matrices are written out as the large brackets, and they have a certain amount of rows. Those are rows. And these are columns. We know that they're rows because if you're rowing a boat, you have to be horizontal. You're going across the lake, because if you were going vertical on a lake, you're dying because you just went over a waterfall. Okay? It is. Seriously, you just went over, what is it called? Niagara Falls. That's what it's called. You're not in a barrel. So what we're able to do is that you can take what's called a coefficient matrix, and I'm just going to look at the stuff that's on the left-hand side. How many variables did we have, and how many equations did we have? 3. So what I'm going to do is I'm going to create what's called a 3x3 coefficient matrix by doing the following. I'm going to write a 1, a 2, a 1, 2, -1, 4, -3, 1, and -2. All I did was took the coefficients, hence the word coefficient matrix, and I put it in the symbols. Now it's where it becomes interesting. Now you need your calculator. Well, you're going to have to figure this one out.
And I already forgot how to work on this.
So what we need to do here is I show you guys a couple of sequences of some shortcut keys to create this thing in the calculator. Once you understand how these things work, using the coefficient matrix is going to help you to see if your answers made sense for systems of equations. Because by a couple of keystrokes, we can get an answer. So what we need to do is hit alpha zoom. alpha zoom, and it comes up as a shortcut key. Got your calculator? You might want to take this out and look at it. It comes up with a thing where it says rows and columns. You want to move the cursors around to create a 3 by 3. Now, what's nice is that if you accidentally screw something up, it'll show you a visual of what it looks like. So let's say you accidentally hit 3 by 4, and you weren't paying attention. And now it comes up with more stuff than you have room for. See how that works? So if you forget what are called dimensions, you can go back and forth. Yes, sir? You have to hit the arrow keys. You have to move the arrow keys and then hit enter. Alpha zoom, and go back up here, and I gotta change to 3 by 3.
I don't move up and down.
You have to use the arrow keys. And now, when you get in here, when you're in here, in order to enter in your data, you just enter the numbers. You have to hit 1 right. Don't hit enter, because it'll jump you out of the matrix. Okay. 2 right. 1
Wait, how
right.
do you? So after 3.
You have to make sure you use the negative symbol for the negative button, not a minus. Because if you use a minus, it'll come up with an error. So right now, you have that in your calculator, I hope, right? So what you're able to do with that now is that it's stored. And what we need to do is, just like we did earlier when you had 3x equals 9, you had to multiply both sides by the inverse. Well, we're going to do the same thing with the matrix, but we have to multiply by the matrix inverse. So what was the keystroke or the thing that I wrote above the 2 that made it a 1/2? The -1. Isn't there a -1 button on the calculator somewhere?
Yeah.
What that does is that it's going to take the inverse of the matrix. There is a way to calculate the matrix inverse by hand. It deals with multiplying down the diagonals and subtracting and stuff like that. If we have time at the end of the school year, it's something that I show you guys how to do. If you look over your shoulder, over Haley's shoulder up there, Izzy did that a couple of years ago. And she did a determinant of was that an 8 by 8 or something like that? It's just, Izzy hates, yeah. It's just awful. It looks really cool, but it just took her forever. It made her do it by hand. It was extra credit. So, I know, I have some great ideas. So now, we need to figure out what to multiply this to. So what we have to multiply it to is we have to multiply it against the matrix of the answers. The answer matrix looks like this. 4, -8, and -1. How many rows is that? 3 by 1, very good. It's 3 rows with 1 column. So we have to create, yes ma'am? Well, just turn it off and turn it back on.
So will this give us the answers?
I'll show you. We're going to create another matrix. Remember, alpha, zoom. We're going to make a 3 by 1. Okay. And if you accidentally did a 1 by 3, it'll be the other way, and it won't work. So put in your answers again. What was it? 4, -4, -8, and -1. Hit enter. X, Y, Z.
Oh, God. It's further equation. This makes me
This is what I need to say. So many
No, that'd be very bad.
Oh, I forgot an English.
I'll figure it out. Okay? So, guys, so the idea here is, yes, you can use matrices to solve the problems, but it's more or less going to be one of the things that you can use to help check the problem. All right, yes, sir.
So double check if we should make some row, because I've read.
Put it in. Remember what that, which problem was that?
It was 37.
So 37 was this one, right?
Problem.
Yes.
No.
Yeah, it was, because you had the, nope.
No, that's this one.
You would have written.
So if I hit the one with 37, it's actually, ladies and gentlemen, it's a good question. So we have what? 1, -2, 5, 3. Oh, crap.
That's what happens to me.
There you go. So it's like.
Anyway, put it in and see what happens. All right.
Are we allowed to use these on the test?
Here's the thing. On the test, when we do the quiz stuff on Wednesday, what we'll have is that I'm not going to take the calculator from you today, but you still have to show your work. All right. The idea is that when you're working with these things, this is just another means to allow you to see if you're getting it right. Oh yeah. Then you get that singular matrix, no inverse matrix. See, what happens is when you try to find the inverse of the one that's a no solution, the inverse you divide by 0 and all things go bad. Well, then you don't do it. No.
Oh, I did 4 -2.
There you go. Yes. That means it's something right. Yeah. That's how you find the inverse, yes. Guys, good question. You always use the -1. Yes. We're not multiplying the matrices together. We're not trying to get scalars and go through and all that. We're just using that. All right. That's it. Yes, ma'am.
So I got 111. Let's say you're on a test and you go check your work and you got the wrong answer. So then, like, you know how many times you write down the right answer that you got? Will we still
It
get
has to
some
match your
points?
work. Has to match your work. Anybody can press buttons. You gotta match your work. The idea here is that you'll see problems like this on ACTs, SATs. Anytime you have a system, it doesn't matter what the dimensions of the matrix of the system is, 2 by 2, 3 by 3, they're all solved with one matrix. That's the idea. I just want to show you a little trick here. Where is it? Those are your answers, X, Y, and Z. And the way that the way that it works is that you're setting it up in this order. That's why it goes in that values of X, Y, Z as it solves itself through. It's solving for that first variable, second variable, third variable. What a matrix does as it's going through, it's doing what's called row swap. It's trying to come up with they call it an identity matrix. By multiplying a bunch of these things together, this was your X column, your Y column, your Z column. The matrix, by using inverses and stuff, it is multiplying itself out to get the coefficient for 1 for X, 0 for Y, 0 for Z. And then as it goes through, your answer matrix was what, 2, 3, and -3? I think that's what it was, wasn't it?
Yeah.
They just, I'm just explaining how they line up. That just means that X goes with the 3, Y goes with the 2, Z goes with the -3. That's what it means as it multiplies itself out. Okay? We may or may not have time at the end of the year to do actually some of this stuff by hand. It's pretty neat how it works. It's kind of cool. Okay? Quiz stuff. What I was saying with that is that we're going to do this on Wednesday. What I have for us tonight is a couple more of these system of equations. I think there's like 5. And tomorrow we'll do some review problems, and then I also have the word problem that I remembered to make a chart with it this time. So I think that's like the last of the big giant word problems that I could find. So we'll look at that one as well, and then we'll quiz and be done with this stuff on Wednesday. That'll get us to be able to start chapter 4 then on Thursday, and then go from there. We actually will use this matrix stuff in the very beginning of chapter 4 for solving systems of equations, because it is really, really fast to do that for quadratics when we have to find a singular value. So, questions, or do you want to do another one like that? No. It's just enough. And to be honest with you guys, more often than not, you're probably picking up that you miss a sign here or there. You write down the wrong number for the wrong problem. It's not that the actual. It's not that the actual arithmetic is all that difficult. It's just trying to keep everything straight. Because this is one of those first times that you actually have to use a lot of space to solve a problem. You have to be careful with how you go through it, because there's no one size fits all to solve it. Everything's a little bit different. Let's see what's the other one here. I think we have a kicker arm, which is funny, it's not your foot. So you get to sign and be the second person on our wall of fame. Because Hannah sucks at volleyball, apparently. That's a joke.
It's not a joke.
Do you know where the printer is outside? Yeah, you forgot to spell his name. Did you spell your name wrong? Why did you spell your name
I
wrong?
didn't spell my name wrong.
Seriously?
I just dotted the I twice. I'm gonna repeat that. That's terrible.
Just erase it all. Start over.
He's spelling it with his mouth as he's trying to do it. He's going.
Smart words are not my. I'm doing good.
Do you want to just use an X? Like Fred Flintstone it?
I didn't spell it wrong. It's just bad. It's close enough.
That's kind of embarrassing. No offense.
Did you spell it right?
I spelled it right. It just looked bad.
Famous last words. You know where the FTL little printer is out there? What page is that? 21. All right. So on here then, no, I didn't have. Oh, I know. I need you guys to do me a favor. Open your Chromebooks real quick. Apparently.